Today we're going to be talking about graphing an ellipse. So an ellipse is a set of all points whose sum of two distances from two fixed foci is constant. So you might have seen an ellipse, you might call that an oval in the past, but it is an ellipse, okay? And some important things to remember, we have that A is greater than B. So if you look in these formulas, you're going to have A squared and B squared on the denominator, so we'll talk about that in a little bit. But A is always bigger than B. And in this formula, c squared equals a squared minus b squared, that looks very familiar. It looks a lot like the Pythagorean theorem. But this here is going to be used to find the foci. So those points where all of those other points are equidistant from those two foci, we're gonna work on finding those things. Okay, so we have two different types of ellipses. We have either horizontal ellipses, and that's going to be where they're stretched out more horizontally, so they're going to be short and fat ellipses, and in that we have x minus h squared over a squared plus y minus k squared over b squared equals 1, and the major axis is going to be the line y equals k. We'll get to that later on. We'll get to that as well. This formula should look somewhat familiar. The x minus h squared and the y minus k squared, that all comes from just like our circle formula. So the center of a circle or the vertex of a parabola, it's going to be that same type of thing. We could also have a vertical ellipse, and that means that it's going to stretch more up and down, so it's going to be tall and skinny. And our formula looks exactly the same over here, except instead of having x minus h squared over a squared, we now have b squared. Plus y minus k squared over a squared equals 1, and the major axis is going to be x equals h, whatever that is. So if you're looking at this, since a is always bigger, since a here is under the x's, it's going to stretch more in the x direction. Since a is under the y's, it's going to stretch more in the y direction as we go. Keep all those things in mind. Now there are 7 total things that we're going to be finding for these. So we're going to have the center, we're going to have vertices, we're going to have foci, we're going to have the major axis, we're going to have the minor axis, and then we're having domain and range. Okay, so those are the things that we're going to be finding. A lot of them are what you've already been working on, and we're going to kind of see what they look like as we practice a couple of examples here. Okay, so we're going to be given an ellipse formula. We're going to have to find the center, vertices, foci, major and minor axes, domain, range. We're going to graph it. And you don't necessarily have to do all of those things in that particular order. We know that this is an ellipse because there are fractions, and we've never seen fractions with any of ours. We're also adding those two fractions together, and that's important for an ellipse. So let's get started. So our center is going to be exactly the same way we found the center of a circle. So we would make this be 4, -5. So I'm going to go ahead and plot that. Okay. In order to get the vertices, we need to know what A and B equal. Eventually we're going to have to figure out what C is, so we're going to write that down as well. So A and B are going to come from the square root of these numbers, since in our formula it was a squared and b squared. And A is always the bigger number. So if we take the square root of 25, we get 5, and the square root of 9, we get 3. Since 5 is bigger than 3, we know that 5 has to be our A value and B is 3. Now, it's also going to be important to know that this 5 is associated with the x's, and this 3 is associated with the y's. Alright, so now what that means is from this center, we're going to count in the x direction 5 spaces. So that means we're going to go 1, 2, 3, 4, 5 spaces to the left, 5 spaces to the right. So our vertices, we're going to go ahead and write those down. So we had -1, -5, and 9, -5. And then we're going to count in the y direction 3 spaces, so both up and down. We're going to count 3 spaces, and so those coordinates would be 4, -2, and 4, -8. And it doesn't matter what order you have those in, as long as you have all of them, you're good to go. Now, it should be the case that since we're having a higher number under the x's, that it should stretch more in the x direction, which it does, so we're good to go. So we're going to connect these as best as we can, making it be an ellipse. It might not be 100% perfect, and that's fine, but you're going to do it as ellipse-like as possible. All right, the next thing to find is our foci. And in order to find those, there are two focus points, foci, plural. We have to use the formula c² = a² minus b². The way I keep track that this is a minus is it's always opposite of whatever this sign is. So since this is a plus in between my fractions, I'm going to use the opposite of that. So we're going to have c² equals 5² minus 3², which is going to give us 25 minus 9. So c² is going to equal 16, so our c value is 4. Now, a and c are always associated with the same letter, so that means that our c value of 4 is going to also be associated with the x. What that means here is we're going to count 4 spaces, both left and right, and mark those points. So our two focus points are going to be 0, -5, and 8, -5. Okay? Next is to find the major axis and the minor axis. So we use MA for major and MI for minor. In this graph, which one of these axes would be longer? That's going to be the major axis. So it's going to stretch more this direction. So we're going to dash that into our graph. That crosses the y-axis at -5. So y equals -5 is our major axis. The minor axis is going to be the one that's shorter. So this is short and fat, so this is our minor axis here. It crosses the x-axis at a +4, so our minor axis is x equals 4. Domain and range act exactly the same way that they have in the past. Will these have brackets for everything because everything is contained, or do we need parentheses for infinity symbols here? Well, everything's contained within this ellipse, so your domain and range are going to have brackets. It starts and ends at particular values. So our domain is going to be from -1 to +9. You can either get that here, looking at the smallest and the biggest x values, or you can do that over here with your vertices as well. And then range is going to be our y values. Remember, we go from least to greatest, so here was -8, and up top there is -2. So going from least to greatest is -8 to -2. And that is everything from start to finish. Now, you can also do some of these things using a formula way instead of counting on the graph, so we'll talk about that in our next example. Keeping in mind how my graphs look is exactly how your graph should look. Okay? Alright, so if we have x + 2 squared over 16 plus y - 3 squared over 49 equals 1, first we got to figure out, well, we know it's an ellipse because of the plus sign, the fractions, it's got both variables squared. The next thing is to figure out our center, and then start figuring out what direction it's going to go. So our center is going to be -2, +3. And I don't know if I mentioned this before, but I'll mention it again, even if I did. X always comes first in an ellipse. X always comes first in an ellipse. That makes it easy for our center, but A is always bigger, so you got to watch out for that. Okay. A for this is going to be 4, and B is going to be 7. This time, time out, what do we know? I just said A is always bigger. So A is 7, and B is 4. Since the 49 is under the Y's, A is associated with Y, and B is associated with X. That means that C, whatever it is going to be associated with the Y's. All right, let's plot that. -2, +3, there's our center. Okay, you can also do this formula way to find the vertices. So I know that I'm going up or down 7 spaces, so I can either add or subtract 7 to that y coordinate of the of the center. So that means I would have -2. If I added 7, I would be at 10. If I subtracted 7, we would be at -4. Okay, so we can plot those -2, 10, and -2, -4. If that confuses you and you just want to count on your graph, you're more than welcome to do that as well. All right, and then we would go left and right 4 spaces. So we're going to go and add or subtract 4 to or from this. So if we subtracted it, we would be at -6, 3. And if we added it, we would be at 2, 3. So we're going to plot those. -6, 3, or +2, 3. And the bigger number is underneath our y, so it makes sense that it's stretching more in the y direction. So we're going to connect these to make an ellipse the best that we can. All right. Next thing, focus points. In order to find the foci, you need to know what c is. C squared equals a squared minus b squared. All right, so we're going to have 49 minus 16, which is going to give us that c squared is 33, which means, working backwards, we have the square root of 33. Now, it's okay that it's a radical. It's okay if you can simplify it, you're going to simplify it. That's okay as well. We're going to count in the y direction the square root of 33 spaces. Well, that's going to be roughly what? Well, it's in between 25 and 36, which means we're closer to 6 because the square root of 36 is 6. So we're going to go a little bit more than 5.5 spaces. And we're going to put those x's. And it's okay that they're not exact. Okay, so those are going to get x's. Now, for those, since we don't know the exact coordinates of those, we know that we're starting at our center, and then we're either going up or down radical 33 spaces. So we're going to take the y coordinate of our center and either add or subtract the radical 33 to or from it. And it's okay to leave it like this. There technically still are 2 focus points listed there. They are just, there with a plus or minus. All right, next thing. Major axis and minor axis. So here the major axis is the one that's longer. So that's going to be that one there. It crosses the x-axis at +2. I take that back at -2. And the minor axis then is going to cross the y-axis at a +3. Should your major or minor axes ever have the same variables with them? No, they're perpendicular with each other, so that means that one should be x and one should be y. All right, last things here, domain and range. You can either get those from the graph or from your vertices. So the domain, we're going from -6 to +2, from least to greatest, and range, we're going from -4 up to a +10. So with all of these things, you just got to make sure you're looking at the particular parts that you need to and keeping track of everything, and you're good to go.